We're going to start off with creating a dictionary that holds the values of which three-letter combinations code to which amino acid here. Then we're going to define some functions. So this one, complement DNA to DNA, takes a DNA strand and finds the complement of it and puts it into a new list, which is then returned. This next one, complement DNA to RNA, will take the complemented DNA strand and find the RNA strand that it connects to, and then it's going to add that into a new list called mRNA list, and it's going to return that. Right, so next is the introduction to our code, where we're going to explain what it will do. We let the person using the program input the name of their text file stored on their computer. Then our code takes that name and searches for a file with that name on the computer. After that, it will open up the file and read it. Then the \n at the end of the file will be deleted. Right, so here the file is opened, and then it's read, and then it's turned into a list. And then we have the exceptions, see if there's an error, then it's going to tell the person reading that there's an error, and it's going to exit out of the code. Next, we're just checking that the text file only includes the letters A, C, T, or G in capitals. Otherwise, the program will not continue, because that's the only way it can work if there's A, C, T, or G. Right, next, we're using the functions that I just talked about above to create our mRNA strand. After this, we're making two new mRNA strands by taking the first letter off it to create mRNA2, then the first two letters of mRNA to create mRNA3. So this way we have three different mRNA strands, all originating from the same DNA strand, right? So then we're going to make those into strings, and then we're going to make mRNA lists into lists within lists with the letters divided into blocks of 3. Then assigns these lists to new variables. So you see that all the variables have 3 of them. So amino acid chain 2, and 3. That's because there's going to be 3 reading frames at the end. There's 3 mRNAs, so everything's going to be in groups of 3. So here we're just making sure that the list, there's no list that has a section of letters less than 3 in case a strand isn't a multiple of 3. Then we're going to make the list of lists into a list of strings here, and then we're going to convert the list of the mRNAs into 3s into its equivalent protein strand using the provided dictionary A table, which is above at the beginning. This is called translation. So yeah, basically it's finding the protein chain that the mRNA codes for. Right, next we're going to check for methionine stops, start, and interrupts in strands. So here, so that's the code for that. So for 1, 2, and 3. Then here we're doing something that's kind of purely for the aesthetic of the code, which is for the output, to see how many lines are needed to link the mRNA strand protein strand. Here using a while loop. Right, and so here, these if statements choose if the output will say the word is or are, and then met or mets, depending on how many mets are in the output strand. So if the output says there is 10 met or there are 1 mets, the grammar does not make sense, so this code is purely just fixing the grammar mistakes in the output. Right, now we're getting to the output, so it's just going to print loads of different things, which I'll talk about later when we're actually run the code. And so here's an important part. So this part of the code analyzes a strand of mRNA strand and protein using this above. And it's going to see what the qualities of it are. So, yeah. And then we're going to use frame points, and we're going to allow, so each mRNA strand analyzed will have a specific amount of points based off the qualities it has. The strand with the most points is the strand with the best quality and makes the best reading frame of the 3. So here we're going to say if there's a start at the beginning, then we're going to add 1 point to frame points. If there's a stop at the end, we're going to add 1 point to frame points. If there's no interrupting stops, then we're going to add 1 point to frame points. So this is just kind of analyzing what's happening in the frame. So this is going to happen 3 times because there's 3 different frames. And then here, we're ensuring that the code will be able to find the best strand even if some strands have the same amount of points, frame points. So for example, it is ensuring that if frame 1 and frame 3 are tied, okay, so yeah, so if they're tied, then there will be 2 possible answers. So here we're making a new list with the number values, so frame points 2 and 3. Here we're making a list with the names, so frame 1, frame 2, frame 3, and here we have a dictionary. So if frame points 2 and frame points 3 Sorry, excuse my coughing, I'm a bit sick. If they're all different, then we're just going to use max function and find the max of this frame dictionary, and then that will be the correct frame. And here, for example, we have a tie. So if so this one is frame 1 and frame 2 have the same amount of points. Then there are 2 correct answers, so tie 1 and tie 2. Right, and here, if all of them are the same, frame points 1, 2, and 3 are the same, then there's no possible answers. So then it will just say not available. Now we're going to let the person reading the code decide which one's the best. So if they choose either the correct frame, if there's only one right answer, or if they choose correct frame tie 1 or tie 2, if there's a tie, then we're going to say congrats, you chose the right one, or if they don't, then you didn't choose the right one. Okay. So now we're going to run through the code. So program's called Genie. Talks about the purpose. I have ensured that the name of the file's on my desktop, and I'm going to enter the exact name of the text file that the Strand start episode, and then enter the username of my computer as Malin Leven. Right, so here we can see Genie. It's an amazing name. Here we can see the inputted gene, and then the antisense strand or the complement strand, then the mRNA. Here we have frame 1 and all its different qualities. We have the length, and we have the RNA and the protein. Here we have frame 2, see it's 1 less than the one above, all its different qualities. Then we have frame 3, 1 less than the one above, and 2 less than frame 1, and all its different qualities. So now it says we have to decide which reading frame you think is the best, and I can only select 1. So remember that the most ideal reading frame would have a met at the front and a stop at the end with no interrupting stops. Now input the reading frame you think is best out of frame 1, frame 2, or frame 3. So I think frame 2 is the best because it has a met at the start and a stop at the end. So I'm going to write frame 2, and then it says that I've chosen the correct answer. That's the end of this screencast. Thank you. Goodbye.